Okay, so this is one of these second partials with the chain rule. Now, note it refers to example 496, and in example 496, some of this is already worked out. In particular, here it is, example 496. We've got this setup of variables, and the problem is already this example has already computed the first partial with respect to theta. Right, so I'm just going to take this as a given, because there's where it came from, and this is what it turns into. And we're just going to compute the theta partial of this. Okay. All right. Now you do have to be a little bit careful with this. Let's see here. By the way, let me copy that down here. So the first partial of z with respect to theta is zx times negative r sine theta plus zy times r cosine theta. Okay. All right. Now, let's also remember our little diagram of variables and what depends on what. And that's here. I'm just going to leave that up there while I do this calculation here. Okay, so we're going to be taking the theta partial of this thing. Okay, all right, so now what depends on what? Well, let's see here. Now, does Zx depend on theta? Well, here's Zx, here's theta, and yeah, it does. It depends by way of two intermediate variables. So when we're taking the theta partial, this is something that depends on theta, but then again, so is this. So the first thing we have to do is write down the product rule, and we kind of did that in the example in the text here. This was we took this. Now we were taking our partials at that time, but the first thing we wrote down was the product rule. But we got lucky that this ended up being 0. It just won't end up being 0 in this next example here. Yeah. Okay. Right. Okay. So product rule. First we have theta partial of zx, and then times negative r sine theta. Then we have plus zx times the theta partial of negative r sine theta. So this is the product rule as it applies to that term. And then same thing here. So we got to write this down too. And it's in fact, I probably should have done this with the paper sideways so I'd have enough room to write this all out. I'm going to have to use multiple lines here. So let me say plus, now, theta partial of zy times r cosine theta plus, and then zy times theta partial of r cosine theta. By the way, you'll notice that I've written this out. I mean, I could have, instead of writing theta partial of r cosine theta, I could have computed that derivative instead of writing it down. I went ahead and wrote it down anyway, and then I'll compute it in the next step. And the reason why is because there's so many terms that are going on here that it's really easy to get confused. And wait a minute, did I finish the product rule, or did I just recopy? Wait a minute, what did I just do? Right? So I say take it slow. Right? All I've done here is sort of write down the product rule. I haven't actually executed any derivatives yet. And I want to recommend on these, don't try to combine too many steps. Don't take these gigantic algebraic leaps when there's this much going on. Yeah.
Yeah, I can't really see, but in the second term, is that negative r sine theta?
Oh, yeah, excuse me. Yeah, this is negative r sine theta. Now, I'll start writing bigger. I guess it is a little small, isn't it? Sorry about that. Yeah, so this is theta partial of zx. This is negative r sine theta. That's zx, and that's theta partial.
Okay.
Theta partial of negative r sine theta. Yeah, exactly. Okay, I'll write a little bit bigger next time. Okay. Okay, so now let's get going here. Gosh, there's a bunch of stuff that's going to be here. So the first thing we have to do is now write down what is the theta partial of zx. Well, on the diagram. So up here, theta, zx, there's two intermediate variables, x and y. So the next thing I'm going to do, all I'm going to do is write down what does the chain rule say that this is. And what it is partial of zx with respect to x, partial x with respect to theta, partial zx with respect to y, partial y with respect to theta. That's just that. Cool? Okay, so now that still gets multiplied by negative r sine theta. And I'm already kind of wishing I had more room here. No, I guess we'll be fine here. So now plus zx, can't really do anything with that. And now I guess I can go ahead and calculate what is the theta partial of negative r sine theta. Okay, well let's see, the theta partial of sine theta is cosine theta. So I just have negative r cosine theta. Is that all right? Okay. Plus, okay, now we've got to go down to this line here. So theta partial of zy, same deal. There's intermediate variables there, both x and y. And so I've got partial zy with respect to x, partial x with respect to theta, plus partial zy with respect to y, partial y with respect to theta. That's just this term, this factor. Yeah. So it's still times r cosine theta plus still zy. This derivative I can now calculate because I'm taking the theta partial of r cosine theta, and that's going to be negative r sine theta. Okay, is everybody happy? All right. Okay, so moving along. Now, some of these things I can simplify. Partial of zx with respect to x. Well, that's what zxx, I mean, that's just that partial derivative there. Right. Partial of x with respect to theta. Oh, yeah, I mean, x is r cosine theta, so the partial with respect to theta is negative r sine theta. This is zxy. This is, well, let's see, partial of r sine theta with respect to theta, so that's r cosine theta. This is times negative r sine theta, and then I have plus zx times, this is still negative r cosine theta. Fine, same deal over here. I can simplify a lot of this stuff. This is zxy, negative r sine theta, zyy, r cosine theta, the r cosine theta there, still there, and then again recopying zy, negative r sine theta. Whew, okay, bunch of stuff, yeah.
How did it, in the zxy r cosine theta, where did the r cosine theta come from?
This right here?
On the first line.
This right here?
Yeah.
Oh, yeah, so this is zxy. This is the partial of y with respect to theta. So remember, y is r sine theta. R sine theta, take the derivative with respect to theta, r cosine theta.
Okay.
Yep. Right. And then let's see here now. Well, we're mostly done. Now it's just a matter of kind of collecting terms. We have a certain number of zxx terms. Let's count zxx's. Well, there's actually only one. Here it is, zxx. But it's multiplied by negative r sine theta and then another negative r sine theta, thus making r squared sine squared theta. Okay. Now let's count zxy terms. Well, there's two of them. So we've got to be a little careful with this. Zxy. On the one hand, I have zxy times negative r squared sine theta cosine theta. On the other hand, over here I have ZXY times negative R squared sine theta cosine theta. It's exactly the same thing. So in fact I shouldn't have written a plus there. I have negative 2 ZXY R squared sine theta cosine theta. So these two terms collect because they're identical, as it turns out. Kind of a weird coincidence because here you had the cosine and then here was a negative sign. Here you had a negative sign and then it just happens to kind of work out that way. Then you have ZYY R squared cosine squared. But then don't forget this stuff over here. You also have minus ZX R cosine theta and then minus ZY R sine theta. Yeah. There's a lot of details. I mean, we filled up an entire page with algebra here, but notice that all it is okay, sure, it's volume. Yeah, lots of volume, right? But we're just following the rules as required by, which variables depend on what, and then just simplifying as we can, and then trying to be as neat and organized as possible with it. So it's not that different from what we did here. We just didn't get so lucky in that, this magically disappeared and that magically disappeared. And so, in some sense, what we just did is sort of twice as much algebra. Yeah. Okay, is everybody happy with this problem?